to show you how to solve an exercise by using a tool called PermaLearn. So we have exercise on chapter 7 and exercise number 27. They want us to determine the internal normal force, shear force, and moment at the point C and D, and in the simply supported beam. For point D, it's located just to the left of the 10 kN concentrated load, so we can see it here. So now we can find our tool by searching PermaLearn. Yes, I already searched it, so you can it show here. It's PermaLearn.xyz. Yes. So this is our tool. So this tool is only used for 2D structural analysis. So for the 3D one, we cannot do on this tool. So it's for 2D only. So now let's go back to our exercise. So we have for the exercise we have only one member, as you can see here, and it starts from A to B. So we just go to our website or our tool, PermaLearn, and then we can see the word member here. So we just click it here, and so we start to draw it. So we can input the number here, and then it will be show the free body diagram in this area. So I choose to start our beginning x coordinate at point 0, also y coordinate at point 0, and for the horizontal distance, it's the distance from the beginning to where that our member ends. So let's go back and check. So our member ends at 1.5 plus 1.5 plus 1.5 and plus another 1.5, which are 6. So we just right here 6. And for the vertical we don't have, so we just keep it like this, and then you can scroll down and then click add. So we have, as you can see, we have our first member here. So yes, we only have one member. So now after we draw the member, we can add the support. So there are two support in this member. The first one is pin support, and another one is roller support. So we can see here, this is the verse support. So we just click on here, and then click here, join coordinate. So we have two join coordinate. First one, point A at 0, 0, which are here. So we can, as we saw here at point A, there is a pin support. So we click point A, and then support. For support type, we click pin support. So we just click on pin support, and then we click add. So here this is the sign of the pin support, and another one is roller support. So we just change the point here, and then click on roller, and then we just add. Click add. So okay, this has happened because I clicked so many times. That's why it's right like this. So after we add our support, we can start to add the load. So we also have two type of load, which are linear distribution load, and another one is point load. So we go back, and then we can see the word here, linear distribution load. So yeah, this is our member. We just click here, and then our load type is vertical load, so we just click the vertical here. And this time from the beginning join is 0, so we just keep 0 here, and from the end join is 3, so here 3, so it end here. So we just write number 3 here, and we don't have okay, so our beginning load is 6, but we take positive upward, so we write -6, and end load is 0, so we just keep 0 here, and then we just click add. So yes, this is the picture of our linear distribution load. So, and then another load is point load, so we just click on the word point load here, and again we only have one member, so we just click number 1, and this time from the beginning begin join, which are 1.5 plus 1.5 plus another 1.5, it's 4.5, so we just write 4.5, and we don't have horizontal force, so we just keep it here, and we only have vertical force. And again, as our website, our tool take the positive is upward, so we just and our load is downward, so we have to write -10 kilonewton, and we don't have any couple moment, so we just keep it 0. So, and then we click add. So this is the free body diagram of our exercise. So now we can see and check it. Yeah, it have here we have support, 2 type of support, pin and roller at the beginning and also at the end. And for the load, we have 2 type of load, linear distribution load and point load. Yeah, so now we can click on the solution and see. So what is the shear force at point C? So where is our point C? Our point C is at the distance 1.5 from the begin joint. Okay, so we have to, yeah, here is we can okay, we start from normal force, and then we click normal force, and then we click display. Okay, so here is our point C. So normal force is 0, and for the shear force, okay, shear force is equal to 3.25. And then the bending moment. So okay, and then click display. Okay, for then bending moment is equal to 9.375. So yes, now we got the answer at point C. Now let's go to point D. So point D is the distance here, it's 4.5. So here 1, 2, 3, 4, 4.5. So bending moment at point D is 13.5 kilonewton meters, and shear force is 1 kilonewton meters, and for the normal force is 0. So yes, you guys can write down the answer, and let's check on the our solution. So yes, here is the exercise 27 from chapter 7. So this is the answer. So yeah, it's correct. So because our normal force at C0 shear force is 3.25 and moment is 9.375. Normal force at D0, shear force is 1 kilonewton, and bending moment is at 13.5 kilonewton. So this is how we use PermaLearn to solve 2D exercise for our static course.